Okay, everybody, this is a quick review of arithmetic sequence. Remember, arithmetic sequence is about additions and subtractions. And here are four things we're going to cover. So let's start with the first to define the general equation for arithmetic sequence. First, we need to know what is the definition of it. Here we have an example, 3, 7, 11, 15, 19, 23, etc., etc. Did you notice that the term behind it is always 4 more than the term ahead of it? So the definition of arithmetic sequence is that if there exists a number and we use D, and we call that common difference. In the example listed above is the number 4 equals D, such that a n plus 1th term equals a nth term plus D for any integer greater or equals than 1. Note that it's integer, right? In this case, our D is 4. So let's look at the example below. 34, 27, 20, 13, 6. So the term behind it and the term forward, that's -7 in each term. So here, my D equals -7. That's my common difference. Okay, I'm going to move up this page. So let's say if you don't remember in the exam, you blank out. Just analyze it. The first term is A1, right? The second term is A2, so it's A1 plus D. The third term should be A2 plus D, which is A1 plus D plus D. Okay, notice that there are 2 D's there. Now, if I do another one, it's A4. It should be A3 plus D. A3 is A1 plus D, and then there is one more D here. So here it's A1 plus 3D. And if I summarize it, it's A1 plus 4D. So if you keep going like this, you will see that if I want to seek the answer of nth term, I should use the first term, A1, right? And then plus n minus 1. Notice in this case, n is 4. N minus 1 times common difference. That's the generic formula for any term in arithmetic sequence. So let's put that let's put that on top here. AN equals A1 plus n minus 1 times D. That's our arithmetic sequence. If I need to find the 14th term of this one below, of 4, 7, 10, 13, 16, notice that the common difference is 3. So if I want to find a 14th, A1 is 4, right? A1 equals 4 plus 14 minus 1 times D. And that would be A14 should equal 43. And in other words, let's just do a quick summary here. What do I need? I have 4 variables in here, and really 3 variables because the n here and the n here is embedded in there. So I need 3 variables, and as long as I'm given 2, I can find out the 4th one, or the 3rd one, to have the complete answer from that formula. So look at the example here, number 3. Find which term. So AN equals 301. And we're using the same example in number 2, which means my D is still 3. My A1 is 4. Actually, I made a mistake on top. A1 is 4, okay? So let's see. Now AN is 301. So it's 301 equals A1, which is 4, plus N, I don't know, minus 1 times D. That's my setup. And if you solve that correctly, you should have N equals 100. Okay. Let's look at the next one. This one is a little bit different, but it's still the same concept. The third term of the arithmetic sequence is 8. So A3 equals 8. And the 16th term is 47. Find the A1. So what's A1 and what's D? Then construct the infinite sequence using the first 5 terms. So let's see what we can do. If A3 equals A1 plus 3 minus 1 times D. And now I know A3 is 8. It becomes A1 plus 2D. That's one formula. And the other formula is, and I changed the color of my pen. So A16 equals A1 plus 16 minus 1D. And then A16 is 47 equals A1 equals 15D. Okay, now go to another color. Now I have a system of equation, that I have to solve. So I'll take the gold one first. A1 plus 15D equals 47. And the second one is A1 plus 2D equals 8. And notice to solve system of equation, I like to use elimination. I use equation 1 minus equation 2 so that these two A1s can be canceled. And now I have 13D equals 39. So D equals 3. And once I find D equals 3, I plug it into any of the one. I like to pick the smaller numbers. So 8 equals A1 plus 2 times 3, which is 6. And that would give me A1 equals 2. So I found A1, I found D, and I can just keep going from there. Construct the series. It's A1 is 2, plus 3 is, plus 3 is 5. That's a 5. Plus 3 is 8, 11, 14, and so on and so forth. Okay, this is the first 5 terms of my sequence there. Okay, the last part of this unit is arithmetic series. So remember the difference between sequence. Sequence is just the order of things. Series actually is the sum of all the arithmetic sequences. So sum of arithmetic sequence. Okay, and the notation we use SN stands for sum of the arithmetic sequence. So the example here is 1, 2, 3, 4, and therefore as 4 is simply 1 plus 2 plus 3 plus 4, and that should give me 10. Okay, and in this case, obviously, it's A1. This is arithmetic sequence, right? A1 plus D, A1 plus 2D, and A1 plus 3D. And my formula should be M over 2 times A1 plus AN. And I think you probably have heard of the Gauss theory or the story about how Gauss came up with this. If not, just Google it. It's quite a fun story. So here you go. Find the sum. As soon as you see sum, you want to think about the arithmetic sequence, arithmetic series formula. I always get them flip-flopped. Anyways, so it's the first 100 natural numbers. Remember, natural numbers are simply 1, 2, 3, 4, and so on and so forth. And so here is your A1, and here is your A100, right? And then the common difference between each one is just 1. So let's list it out. A1 equals 1. N I have 100, and AN is 100. So there's your answer there. 100 divided by 2. A1 is 1. AN is 100. So you should have 50, 50. So this is the exact problem that Carl Friedrich Gauss did. The mathematician's name is Carl. I think it's Friedrich Gauss, Gauss. So Google his name. When he was I think 7 or 8, 9-year-old, his teacher was trying to trick him and put this problem on the board, and 1 plus 2 plus 3 all the way to 100, and all the other kids started to adding it up, and he figured out a pattern, and he answered it in 3 seconds. So at the age of 7 or 8 or 9. So quite amazing. But it also tells you that math is really not hard once you see the patterns in it, right? The next one, find the sum of the first 15 terms of the arithmetic sequence 4, 7, 10, 13. Obviously, the D here is 3, A1 is 4. And then we want to, in order to find we want to see what is S15 is. In order to know S15, I need to first find A15. A15 is A1 plus 15 minus 1 times D. A1 is 4 plus 14 times 3. I should have 46 as A15. And now I just plug it in. So in this case, it's 15 divided by 2n over 2 times A1 is 4, A15 is 46. So my final answer is 375. Okay. Okay, the last problem, it looks intimidating because of this funky sign called sigma. We call it sigma. And then we add even more weird letters, k equals 1 to 130. So all this means is the sum of this formula, 4k plus 5, when k goes from 1 to 130. 1, 2, 3, 4, 5, 6, all the way to 130. So in this case, it's asking us to find the sum. In other words, this is really a different way to writing the arithmetic series here. And if I want to break it down just as an experiment, my A1 should be when k equals 1, so it's 4 plus 5 equals 9. My A2, so 2 times 4 is 8, 8 plus 5 is 13, so on and so forth, right? You can figure it out yourself. 3, 12, so 17. So obviously, between each one, the D, the common difference is what? It should be 4. So from here, I find out that my common difference is 4. Now, in order to find the arithmetic series, I also need to know the last term, right? So the last term is A130. So this goes all the way down to A130, should be A1 plus 130 minus 1. Oh, I'm sorry, A130, I can do it this way, or I can just simply plug it in. 130 is 4 times 130, it's 520 plus 5. So it's 525. Now I can use my arithmetic series, n over 2, I think, right? Plug it in. 130 over 1 times A1 plus 525. And if you calculate this and your final arithmetic series is, that's 3, 4, 7, 110 is your final answer. Okay, so as you can see, it's really not hard, but it's really important to understand the concept. Arithmetic sequence is about additions and subtractions, mostly about positive numbers, but there are a couple of examples that's negative numbers. So plus and minuses only. There's no multiplication, no square roots and or powers and exponents and that sort of thing. Keep it simple. Once you find out it's a sequence, find out the common difference, find out the first term, then you can go from there and derive out of whichever term you need. Once you master that, you add all the series together, you get a arithmetic, all the sequence together, you get arithmetic series, which is another different formula. And there are two different ways to express the same formula. Okay, so play with it and do some practices at home. I'll see you in class. Bye.